from a Dying World, the podcast. For more than a decade, I've reviewed over 1,000 books that are mostly science fiction, horror, and bizarro. This feed will feature bonus audio I have produced over the years, as well as a monthly digest of reviews based on what I've read each month, plus the occasional bonus material about my own fiction. Thanks for listening.
All right. Today I am super honored to welcome Professor, author, and researcher Dr. Avi Loeb to the Postcards from a Dying World podcast. He is the first astronomer that I've had on because I've mostly had horror writers and science fiction writers, but he's a dream guest of mine because I really appreciate how speculatively he thinks and how outside of the box he thinks as an astronomer. So welcome, Dr. Loeb, to Postcards from a Dying World.
Thank you for inviting me.
Yeah, we're going to talk about your new book, Extraterrestrial, in a little bit, but let's give the listeners who might not have, who are not big astronomy nerds like me, who might not know who you are, like, what's your background and how you got into this field?
Right, so I started practicing astrophysics around 1987 or so, a long time ago. I finished my Ph.D. in a different field, and then I entered astrophysics. That was a precondition for me getting a position at the Institute for Advanced Study at Princeton. And took me a while to learn all the concepts, but I developed my own perspective simply because I was never mentored by someone that told me what to think. And that turned out to be an advantage after a while, after learning all the vocabulary, because I developed interest in things that other people do not work on, that are not curious about. And turned out that it worked out very well. I studied the first stars in the universe, the scientific version of the story of Genesis, when nobody was interested in it, and now it's a major frontier. I also studied black holes, various aspects of black holes, and now black holes are in vogue. You know, the Nobel Prize was awarded this year in physics to the study of black holes. And I'm actually the founding director of the Black Hole Initiative at Harvard University. And my latest interest is in the search for life. Both primitive and technological, advanced forms of life. I don't believe that we are special in any way. I think it's arrogant to think so. And therefore, you know, since the conditions that we find on Earth are replicated on so many planets out there, billions of them, tens of billions in the Milky Way galaxy, and there are trillion Milky Way galaxies in the observable volume of the universe, it's quite likely that you know, we are not alone, and we just need to find out in order to get a better perspective about our place in the universe.
Yeah, and what kind of damage do you think us science fiction writers have done to the concept of finding possible intelligent life? Because look, I'm a science fiction writer, I admit it. So like, I know we like to just have fun with things, but you guys have to like drill down and do the real science. So what do you think, what kind of damage do you think we've done?
Well, I don't think you did any damage at all. In fact, there are two important contributions that science fiction makes. One is to attract young kids to science. And I know of some Nobel laureates that confessed that they started science because they read science fiction early on. And so clearly science fiction deals with questions that are of interest to everyone and are exciting to everyone. These are the most fundamental questions. Are we alone? You know, how did life arrive at Earth? What will happen when we establish contact with another civilization? These are fascinating questions. There are also issues related to future technologies, and science fiction writers came up with ideas that ended up real. It's important to imagine in order to discover new things. Now, the problem I have personally with science fiction is that quite often you find that the laws of physics as we know them are broken in those stories. And I have a problem with that because for my living, I do physics, and when I see something that violates the laws of physics, I just cannot enjoy the fiction part of it. But as long as science fiction is close to being true in terms of satisfying the laws of physics, I have great pleasure reading it. My interest is mainly in science, but I appreciate the value of science fiction, both for encouraging kids to go to science, also because science fiction appeals to the public, and as a result, the public is interested in those questions that now scientifically we can address. So we are at a very special time in human history. For the first time, we are able to address those questions that used to be in the realm of speculation in the past.
Well, okay, we got to get Fermi out of the way, because the Fermi Paradox is the elephant in the room. And there are two things that, whenever I argue about the Fermi Paradox, the first two things that I say is I kind of try to make the analogy that I think we're like, our place, the Earth, our solar system, is probably somewhere like in the Yucatan, as far as, and if you were looking for life or civilization and you started in the Yucatan, it might look pretty desolate, right? And then the other thing that I think with Fermi is that, and Oumuamua might be the thing that's showing us this, is that we just don't know what we're looking for, right? Is that, I think that's basically kind of the starting point of your book, Extraterrestrial.
Right. I mean, the first thing to recognize is that our technologies, as of now, are exponentially developing on a timescale of a few years. So if you imagine what our technologies would be in 100 years, they will be unbelievable. We wouldn't even be able to comprehend them today. And not to speak about 1,000 years or 1,000,000 years. And, civilizations may have been around for billions of years. The sun was formed about 4.5 billion years ago. And we are a relatively late bloomer, so to speak, because it formed at the tail end of the star formation history in the universe. So most of the stars formed before the sun. And if so, there might be civilizations that are billions of years old if they survive. And therefore, they may have very subtle signatures that will take us a while to figure out or to detect. And one thing we've learned from other fields of astronomy is that you need to reach a threshold sensitivity. So for example, in gravitational waves, until 2015, there was the LIGO experiment that looked for gravitational waves and wasn't sensitive enough. 2015, it advanced to a level where as soon as it opened its eyes to the sky or ears to the sky, it within a week detected an event. And then after that, since then, we have already 50 events. And so it's clear that there was a threshold that once you reach a certain level of sensitivity, you will see plenty of events coming from the universe. And I think for in the search for extraterrestrial intelligence, the situation is very similar. We haven't really reached the sensitivity. And once we reach it, we'll find a lot of signals out there. Mm-hmm. Now, there is another issue that it's possible that very sophisticated civilizations are not interested in communicating. They maintain social distancing, which is a concept that is now very popular, very trendy. But you can imagine that once a civilization is sophisticated enough, it can create its own habitat and close itself in a cocoon without communicating with. Why does it need to communicate with anyone else? They have their own environment that they created that is optimal for them, and they live in it. And in this way, they don't risk being attacked or invaded. Now, that doesn't mean that we cannot detect any signal from them, because according to the second law of thermodynamics, any production of energy produces some waste, and so they must have some trash that they throw as they live. And it may resemble those investigative reporters that go to the trash can of Hollywood celebrities and try to find out the gossip about their private life. But we could do that. We can look for trash and figure out even what civilizations that are living in cocoons are doing. Now, there is another very likely scenario, and that is, based on our own behavior. As soon as we develop the technological environment, we developed also the means for our own destruction. And either through a non-conventional war, a nuclear war, or through climate change, or through other events. And therefore, they might be short-lived, so maybe several centuries at most. That's a short fraction of the age of the universe. And that means that they live only for a brief amount of time. And if you don't happen to catch them at that phase, you don't see, you will not see a signal from them. Again, it doesn't mean that we can't find evidence because, there is archaeology where we dig into the ground and find ancient civilizations that are dead by now, not around. We can do the same thing in space. We can look for relics of dead civilizations out there.
Yeah, and I want to come back to space archaeology because I have notes on that.
Yes.
But I do want to, and I'm going to joke around a little bit about this. I'm a huge Star Trek fan, but in Star Trek, April 5th is First Contact Day because that's the anniversary of when the Vulcans and the humans meet. For now, what I'm wondering, because I know everybody wants a spaceship to land and people to come out and, do a salute or whatever, but is October 19th, 2017 going to be a day that will live in infamy because in a similar way? And I'm sure you would want to explain to our listeners what October 19th, 2017 means for humanity.
Well, that was the date that the first interstellar object was discovered in the solar system. By interstellar, what we mean is that it's an object that is not bound to the sun, gravitationally bound to the sun. All the planets are bound to the sun. They move around it in a circle. And then there are other objects, asteroids and comets, that belong to the solar system that keep coming back again and again as they move around the sun. So that defines the solar system. And Oumuamua was the very first object discovered coming into the solar system from outside. And we can tell because its velocity is much too large to be bound to the sun. So it was moving too fast, and its orbit came from outside the solar system.
It came from above, correct?
Yeah, it came from above the plane. So that's another indication that it was not part of the plane of where the gas made all the planets and the asteroids and so forth, when the sun was formed. So this object, first of all, was a surprise because I wrote a paper more than a decade ago where we forecasted how many such objects coming from other planetary systems could visit the solar system. And we calculated and predicted, forecasted, that none will be detected by Pan-STARRS, the telescope that was used to discover Oumuamua, because it's sensitive to objects with a size of order hundreds of meters, or 600 feet or more. And the size of the object matters because we see it by reflected sunlight. So it reflects sunlight. The bigger it is, the easier it is to see it. And so we forecasted that none will be detected, but then here we are. In 2017, there was one. And that implies that the abundance of such objects, if they are moving on random trajectories, is between 100 to 100 million times more than we expected, based on simple arguments. So it's surprising. The fact that we discovered it is already surprising by now. Of course, in the future, there will be better surveys of the sky, like LSST on the Vera Rubin Observatory. They will have much more sensitivity, and they will find an Oumuamua-like object once per month if it keeps coming. So the appearance was a surprise, but then there were many other surprises along the way that at first, of course, astronomers thought maybe it's a comet or an asteroid, just like the solar system objects that we have seen. But then it turned out that it's very elongated. The amount of light that it reflected changed by a factor of 10 as it was tumbling around, spinning around every 8 hours. And that's a very large factor because most objects change by up to a factor of 3 or so. And that means that projected on the sky, the area of the object changed by a factor of 10. And even if you take a piece of paper, which is extremely thin, razor thin, and you project it on the sky, the chance of seeing it edge on is very slim. Most of the time you see it sideways. So that means that this object must have very extreme geometry. And the analysis of the reflection of sunlight from it imply that it's most likely at the 90% level, most likely pancake-like. So it's flat rather than elongated as many depictions of it were.
Right. And most of the visuals had this very fast spinning cigar-like object, but what you're talking about is in reality it's more round shaped, like a disc.
Yeah, most likely a flat configuration and very extreme ratio of length compared to width. And then the Spitzer Space Telescope was trying to find any evidence for gas or heat coming off it, as you find in the case of comets. But nothing was found to a very sensitive level. No carbon-based molecules, as you often find in comets, which emit dust. But beyond that, it deviated from a trajectory that you might expect based on the sun's gravity. And the deviation was such that about 1/10 of the object had to be evaporated if it were a regular comet. So in order to get it propelled, pushed away from the sun at the level that was observed, about 1/10 of its mass had to be evaporated. And we would see that. We haven't seen any cometary tail behind this object. And that's really surprising. How is it that it was pushed away from the sun without any cometary tail? And to me, that triggered the thought that maybe sunlight is pushing it, because we are developing the technology of light sails right now. And in fact, I should mention an anecdote. Just in September 2020, there was another object that was unusual that was discovered by Pan-STARRS, the same telescope. And it turned out this object moves in an orbit very similar to the orbit of the Earth around the sun. So it's bound to the sun, in difference from Oumuamua. But this object also showed evidence for a push by sunlight. And when astronomers integrated the orbit back in time, they found that in 1966, it collided with the moon. So it turns out that in 1966, there was a moon lander that crashed on the moon. It was a mission that was not successful. And then a piece of it, the top part of the cover, was ejected to space. And we have found it. At first, people thought maybe it's an unusual asteroid, but then they realized it's a relic from that collision from 1966. And it did show a deviation from an orbit that you expect based on sunlight. So here is an illustration to the fact that we can identify an artificially made object based on the fact that it doesn't show a cometary tail and it deviates from an orbit dictated by gravity. Now, back to Oumuamua, the question is, what could it be? And we suggested in a paper that was published, scientific paper, that it may be a light sail. That's together with, in collaboration with Shmuel Bialy, my postdoc. And then we didn't even have a press release on this or anything, but the public got extremely interested. And as soon as the public got interested, my colleagues became less and less interested, because I'm not sure why this is the case, but there is this tendency of professors in academia to maintain a distance from the public. And I find that inappropriate, because I think the public pays for the science we do. The public is interested in what we find. And if the public is interested in a question that we address, it's a blessing. You know, we should consider a dialogue with the public and provide all the evidence that we have and continue the investigation. Science is work in progress. I'm not claiming we have the final answer. We haven't gotten an image of this object, but it's at least a possibility that it was artificially produced by another civilization, and we should consider that possibility.
Yeah, and we'll talk about the scientific courage and all that in a little bit, but I want to keep drilling down a little bit on Oumuamua at this point. I want to talk about the concept of the idea that it could be, would it make sense to make a light sail probe in this way? Like to fling an object at a solar system knowing it's going to, I liken it to the idea that you could throw something that you know it's going to catch the wind at some point, right? So you throw something up like a kite and you know the wind's going to pick it up and take it. The idea that Oumuamua might be this probe that they fling at a solar system, expecting it to catch on to the light, go through the system and be able to take data, whatever, get pictures, and then fling back out. I mean, that makes sense, doesn't it? That somebody could speculatively, now we're just being imaginative here, but somebody could do that. This could be an object that's doing that, correct?
Yeah, well, so one other unusual quality of Oumuamua property was that it was at rest relative to the so-called local standard of rest. There is this frame of reference where you average over all the motions of all the stars in the vicinity of the sun. It's called the local standard of rest. And our motion relative to Oumuamua was just the motion of the sun relative to the local standard of rest. So this object was at rest in the galactic frame of reference, the local, it's sort of like a parking lot. If you want to put a car so that nobody would know where it came from, you put it in a public parking lot. Nobody knows where it, so there is no way to trace which planetary system it came from if you park it in the local standard of rest. And that's where it was. Now, only 1 in 500 stars is so much at rest in that frame. So that to me is another illustration of how peculiar Oumuamua was. And what you want, if you wanted to probe the habitable zone, the region where life may exist near a star, you would like the object to go very deep into the system. And that's what Oumuamua did. Now, we don't know if it's, even if it's artificially made, we have no idea whether it's functional or not functional. I mean, there was no radio signal detected from it, but who knows, you know, it may become functional once it finishes the trip. It may be one out of many buoys floating in this ocean that we bumped into, and there are many more. It's just impossible to tell from one object. But all I was trying to argue as a scientist is that this should be a possibility that we entertain as scientists, that is on the table, and let's discuss it openly, the way we discuss, for example, the nature of the dark matter. You know, most of the matter in the universe is called dark matter, most of the stuff that fills up the universe. We don't know what it is. It may be particles of a completely unknown nature. We have no clue. We call it dark matter. And you know, hundreds of millions of dollars were spent as part of the mainstream of astrophysics and physics, trying to find evidence for the particles that make the dark matter, so far without success. That is considered as part of the mainstream. No problem, you know, of spending hundreds of millions of dollars on a specific type of dark matter. For example, weakly interacting dark matter. Let's check if it's that type. There is no problem with the mainstream. But somehow the possibility that a real object that we discovered, which is peculiar and shows a lot of anomalies, that this object should not be even considered to be possibly artificially made, is completely out of the mainstream. Nobody is supposed to discuss it. There is a taboo on it. There is even a paper written by a group of people. You know, when you are in a herd, you feel much more powerful. A group of people saying, no, Oumuamua is natural. Now, they don't provide any additional evidence beyond what I was saying. They just declare it's natural, put it in a very prestigious magazine, and that's it. So they close the chapter on any discussion on this subject. And I find that to be, you know, an unfortunate feature of the scientific community right now, because I thought, you know, that we matured after the experience of Galileo, right? So Galileo said the Earth might be moving around the sun, you know, based on what I see through my telescope. And then philosophers came to him and said, no, the sun moves around the Earth. And he said, well, but, you know, would you mind looking through my telescope? And they said, no, we don't need to look through your telescope. We know what is going on. They put him in house arrest as a result, okay? Now, did that change anything? Nothing. I mean, the Earth moves around the sun. The fact that they put him in house arrest just slowed him down. He was unable to move around freely, express his opinions. But it's just a feature of human culture that, I mean, you can suppress opinions. I thought we learned a lesson from that science is supposed to be open to discussion on all topics, especially think about the fact that this is of interest to the general public. So why avoid a discussion on something of interest to the public when there is an object that shows anomalies? So I just don't understand that. And especially since I wrote papers on dark matter, where I considered the possibility that dark matter has a small charge, electric charge, you know, I regard that much more speculative than the possibility that Oumuamua is artificially made. So just
well, parallel universes and other, you know, that's something that people have no problem talking about with no evidence at all. You know, that's actually real.
Exactly.
And look, I like being speculative about that. I understand that. I think that the parallel worlds is a valid thing too. But one more thing on the direction. It's funny, I'm looking at the questions that I wrote, and you've answered so many of them already with outgassing and the shapes. I had questions on that. And but it was my understanding that Oumuamua in its path came from the direction of Vega. Now I know Vega is 25 light years away. Did it, from what we can best tell, do we think it passed through Vega's system as well?
No. So as I mentioned, the special thing about Oumuamua was that it was nearly at rest in the local standard of rest. So, of course, you know, it could be a coincidence that our motion, the motion of the sun, and the motion of Vega are such that it happened to lie along the path, but the path that Oumuamua took was just as a result of the motion of the sun relative to the local standard of rest. That's it. It was sitting still, and it's not clear where it came from. Now, another point I should make is...
Which is why in the book you say that it's almost like we hit Oumuamua more than Oumuamua hit us. Right.
Exactly. But the other point is the solar system is pretty big. You know, there is the Oort cloud of icy rocks that we see coming at us as comets. That goes all the way to about 100,000 times the Earth-Sun separation, 100,000 times that. So that's the size, the edge, the outer edge of the solar system. It's roughly halfway to the nearest star system, Alpha Centauri. So think about those billiard balls, each of them having an Oort cloud, you know, the planetary systems other than the solar system. They're mainly touching each other, basically. They're rubbing against each other. So you have these Oort clouds, the edges of the planetary systems touching each other, each of them stretching halfway towards the nearest star. And that means that, you know, if you tear apart one of the objects in the Oort cloud and let it fly loose, that you basically cannot really tell where it came from, because it's like those billiard balls that are densely packed and touching each other. So in any direction that you take, you will cross a lot of billiard balls. So obviously you can always say, oh, it came from that billiard ball or it came from another, but it doesn't make any sense. It all depends, you know, along any given line of sight, you will find a lot of them. And just tracing where it came from is impossible, in my opinion, especially because it was sitting in the local standard of rest.
Mm-hmm. Right. Well, and that's one of those misconceptions about Oumuamua that's kind of out there, is like, I saw two different articles that suggested like that we understood that it came from the direction of Vega, and I thought that was kind of a misconception, but in any case, but the idea that an object could be floating out there from another civilization is not so hard to believe when we've got two Voyager probes that are out in the Oort cloud right now, right? And which, to me, the Voyager probes, and I have a bookmark that I've used for the last 5 years for every book I've read that is a Voyager 40-year celebration. So I think about Voyager pretty much every day. And one of the things I think about Voyager is that it's the most impressive thing that we've done as a civilization, is to get an object out there. But if we have a civilization somewhere else billions of years ago that went well beyond us, why couldn't an object come floating through our solar system?
By the way, Voyager 1 is now at a distance where it takes light almost a day to reach us. So when it sends a signal and we communicate with it, it takes almost a day for the light to reach us. Now, Voyager 1 and Voyager 2 are moving relatively slow compared to the speed of light. They're moving at about 1 part in 10,000 of the speed of light. And that's why it would take them tens of thousands of years to reach the nearest star, you know, about 50,000 years or so to reach Alpha Centauri. That's a very long time. It's the time that elapsed since the first humans left Africa. So if back then Voyager 1 would have been launched, then by now, you know, 50,000 years later, it would reach the nearest star. So that's a very long journey.
Yeah.
But of course, you know, as time goes on, we develop more sophisticated spacecraft and they become smaller in size. So what I'm particularly thinking about is something very lightweight and thin that you can launch many of, that costs, you know, roughly the cost of a cell phone, that you can equip with electronics and send out. And that's pretty much the concept of Starshot, the Starshot project that in which I'm involved and in which I chair the advisory board. The idea is to send the probes at roughly 1/5 of the speed of light to the nearest star so that it reaches there within 20 years, within our lifetime. And you do that by having a very lightweight payload that weighs less than a gram, that includes a camera, navigation device, communication device, and a light sail on which you shine a very powerful laser that can launch it to that speed. And light sails, therefore, could be a technology that is the ultimate one, where, you know, very lightweight sails are launched much more frequently than we send our spacecrafts right now. And the advantage of that, if they're cheap and lightweight, you can send them to targets of interest even within the solar system, that, you know, because they don't cost a lot for each mission.
So if you were able to, if you guys are successful with the breakthrough Starshot and are able to really prove that technology, what does that say about Oumuamua? Like, does it help boost the case that Oumuamua could be a light sail, or is it just something totally different?
No, I mean, the fact that this technology works, and by the way, the Planetary Society also launched Light Sail 2, and so this is a technology that is now being, even though it was proposed already in 1924 by Zander, it's being developed now, and it's quite possible that the civilization that has aspirations for space is using it very frequently. And in fact, you can imagine a factory that is producing those sails routinely at a very high rate and launches them, doing it in space. And and in fact, you can even imagine reaching the fraction of the speed of light not by a very powerful laser beam, but by relying on a natural source of light. So just like in Hawaii, you see surfers taking advantage of the waves to gain speed on the beaches of Hawaii. The same thing can happen near a stellar explosion, what we call a supernova in astronomy, where a star consumes all of its nuclear fuel and explodes and becomes extremely bright, of order 1 billion suns for a month. If you park light sails in the vicinity at about 100 times the Earth-Sun separation from the star before it explodes, and you can tell in advance that it's about to explode, if you put a lot of these sails, the amount of light emitted by the supernova explosion can push all of them, like dandelions coming off a flower, they can reach a fraction of the speed of light. And for that, you don't need a powerful laser. You just rely on nature giving you the source of light. And who knows what those civilizations... the point to recognize is that if they're much more mature than we are, they might be much smarter than we are. When I open the newspaper every morning, I'm quite frustrated with how non-intelligent we are, how many mistakes we make. And the fact that we fight each other and we waste so much resources on fighting each other, most of the time it's about fighting each other rather than trying to work together on any subject that you think about. And that includes science, everything. And, when you open a cookbook, a recipe book, you find that out of the same ingredients, you can make very different cakes, and some are much more tasty than others. So I can imagine that out of all the chemicals that were on the surface of Earth early on, we ended up with ourselves as one possible cake that was made out of these chemicals. But I can imagine there are much better cakes that may have been made on other planets, and they're much more intelligent than we are.
Yeah.
So,
yeah. Well, and I hate to geek out on this in a nerdy way, but me personally, I'm wondering, there was a Deep Space Nine episode of Star Trek where they built a light sail ship. It's a father and son episode where they build an ancient light sail ship based on another culture's old technology and sail it. And it's actually one of my favorite episodes of Deep Space Nine. And so it's funny because I was recently talking to my friend who's the engineer that I told you about, and we talked about the breakthrough Starshot, and we were talking about how we both got introduced to the idea of light sails from Star Trek, 25 years ago. And so these ideas have been, and you said they've been out there since the 20s and 30s. It's not that revolutionary in the sense of now making it practical and doing it, what you guys are doing with Breakthrough Starshot. That is revolutionary and it's amazing. But I do want to move on. I want to specifically talk about the book for a minute, Extraterrestrial. So we've made the argument for why Muamua is interesting, why people should care about it. The framing device of your book is to talk about your career. And I pointed out, now I'm going to do this. You don't have to pat yourself on the back this way. I'll do it for you. But what I appreciate about the book is the scientific bravery of, like, we know the scientific echo chamber is afraid to go there with the Muamua. And so to me, the idea of this book, Extraterrestrial, is very bold because it's breaking out of the echo chamber. And I know you say in the book, the field doesn't need more cautious detectives, right? And the reason why you've always been one of my favorites is because I always like how bold you think speculatively about, at least trying to stretch your mind out there to think about things that, well, this might be the case. So give me the argument for the book Extraterrestrial as a whole.
Right. So, as I basically follow what basketball coaches tell their teams. They say, keep your eyes on the ball, not on the audience.
Right.
And I don't really care what my colleagues think. I just want to. I'm trying to figure out what nature is about, and most of the time scientists and in academia worry about their honors, their respect, the image they have, and that is very limiting, and it prevents you from experiencing what kids often experience, in their childhood, which is the thrill of discovering something unexpected. Just because you're open-minded, you are willing to make mistakes. And my point is, if you are not allowing yourself to discover the unexpected, you will never find it. And so, of course, you make mistakes. It's a learning experience, but that's the whole purpose of doing science. It's not to elevate our egos. I mean, who cares about it? And the other aspect that came to my mind, of course, as I matured as a scientist, is, we live here for a short time. So let's just talk about the substance and not, just the way that in Casablanca, this famous movie, the main character said, frankly, my dear, I don't give a damn, so basically, let's just think about the evidence and not worry about what people might say.
Because there's no evidence or the people who think that it's a natural object, they haven't added anything to explain Oumuamua's behavior.
Well, actually, okay, so this is an interesting phenomenon. On the one hand, you have major part of the mainstream people that worked on rocks, that I call them rocks, icy rocks. These are asteroids or comets in the sky. It reminds me of those cavemen that used to play with rocks. And suddenly, suppose you give them a cell phone. They look at the cell phone and it looks just like a rock to them. They say, oh, it's a shiny rock. That's it. So I understand that. Okay, there is no way for them to comprehend the possibility that a rock that is shiny may be something else. Okay, because that's what they saw all their life. But then there are other parts of the mainstream that say, oh yeah, I can explain that. And now they come up with the following explanations. They say, well, it was pushed by sunlight, but it's actually a dust bunny, the kind of thing you find at home. And it needs to be 100 times less dense than air. So just think about an astronomical dust bunny being pushed by sunlight, but then it needs to survive, millions of years of travel. And to me, it sounds a bit far-fetched. Okay, that's one idea that was suggested. Another one is maybe it's a hydrogen iceberg, something that we have never seen before. Now, the reason the conjecture of a hydrogen iceberg came is because then the Spitzer Space Telescope would not see the hydrogen evaporating because it looks only for carbon-based molecules. So you want it to be pure hydrogen. The problem is, as we showed in a paper afterwards, is that such an object would evaporate very quickly. It cannot survive in interstellar space. And then there was another suggestion that it is perhaps the shrapnel, the relics of a disruption of a planet or a big object by a star. So you end up with pieces, and this is one of the pieces. The problem with that is the place where an object like a planet can be destroyed by a star is very close to the star itself. You have to graze the star in order to be disrupted. And at that point, the chance of doing that is very small. So most of the objects, most of the planets, most of the asteroids are orbiting very, very far away from the star, where the disruption likelihood is quite small. Moreover, a shrapnel that is destroyed by the gravitational force of the sun would look elongated, most likely, rather than being flat like pancake. And so that's another suggestion that was made. So you have these conjectures that appeared in the literature by mainstream people trying to explain it with great difficulties. And then at the same time, the majority of the mainstream says, oh, business as usual, there is nothing in it. No reason to worry about it, no reason to discuss it at all. And I find this situation problematic, because if it's so simple, then why are these suggestions being made that are quite challenging to understand? And so at least among those suggestions, you should entertain the possibility of an artificial origin. I mean, that to me, that sounds not very speculative, given that, you know, more than half of all the sun-like stars have a habitable planet like the Earth, where the surface temperature allows potentially liquid water and the chemistry of life as we know it. And since the Earth-Sun system is so common, rolling the dice so many times allows for other civilizations out there. So why not consider? There is nothing speculative in the notion that we are not alone. I don't think it's speculative. I think it should be the mainstream conservative view. However, thinking that the dark matter is weakly interacting massive particles is speculative. Mm-hmm. So something is reversed in the thinking. And I think the reason that it's reversed in the thinking is because the possible existence of other civilizations appeals to the public. And that violates the idea of the academia being an ivory tower where we don't communicate with the public. And where, yeah.
And I think this is what makes Extraterrestrial a really important book, in my opinion, is because, look, in a way, it's kind of a middle finger to Fermi, you know, this whole situation, like, hey, and people want the spaceship to land on the lawn of the White House. They want something like a wow signal. They want something like that. But like, isn't it just more likely that you know, something like the Gaia satellite or Vera Rubin in the future or LIGO is just going to happen to, you know, that you're going to be crunching data that you took months before and you find a little thing. And, you know, for us, you know, I personally, you know, I wouldn't probably have had you on the podcast if I didn't think you were right. And I do think you're right. I think Oumuamua is evidence. I think it is. I think we saw it. I think October 17th, 2017, boom, Fermi was wrong. We saw it, in my opinion. I'm not a scientist, so I can just have fun saying it that way. You know.
Well, we don't have definite evidence, but the point is we should continue to look for similar objects and consider that as a scientific possibility. And then, you know, it will be figured out. So, you know, even if we are not sure at the moment what its nature is, in a decade, we will know. That's the beauty of science. We collect more evidence. So it's not a matter of a belief or a prejudice, or it doesn't matter what we think. You know, whatever is out there, and let's just figure it out. So that's all I'm saying, that let's consider it as a possibility, and therefore let's get excited about looking for the next object that looks strange and shows the same feature and figure out what it is. Now, it's possible that it might be naturally produced, but if it is, it's an origin that we haven't thought about because it's so unusual. And the mainstream people just don't allow for that. Now, the other thing I wanted to comment is when I go on vacation, you know, I usually enjoy places near a beach. And I love to walk on the beach and look at seashells. They have different colors, different types. And every now and then, you know, in addition to these naturally produced seashells, I find a plastic bottle. And the same thing when looking at the sky, at these objects. You know, most of the time, astronomers found rocks, just like the seashells. But every now and then we might find a plastic bottle. Now, even if Oumuamua was not one of them, that's like looking for a message in a bottle. It's a different approach for searching, and it's not based on detecting radio signals as we considered in the past. You know, it's a different approach, and we should consider that.
Right. Well. And I think one of the things that makes Extraterrestrial such an important book too is that, and I wrote about this in my review, is that when we think about the fact that we're not alone, but the idea that civilizations could come and go and there could be one, just the idea of expanding our mind to what the possibility that Oumuamua teaches us is a good reminder as a civilization, like, let's be around long enough to find it, to make contact. And that's one of the things that I really appreciated about the book and why I think people should go pick it up. I want to ask you a few general questions really.
But before you ask me, I should just tell you that your review was the first time that I received a compliment with the word fucking in it. You said that it's a fucking, Oumuamua is fucking rad. Now I had to look what rad means because but I really appreciate your interest in Oumuamua.
Well, thank you. Well, no, and I do want, before I get into some general questions, because I have my favorite astronomer on the other line of Zoom, and I can't not take advantage of that. But I do want to put it out there that people should, by the time this comes out, the book should be really close to release, if not out. And my favorite place for people to pick up books is bookshop.org, and you can select a local bookstore wherever you're at to support your local bookstore. But if you don't have one you want to support, Mysterious Galaxies is our local science fiction bookstore here in town. I'm working hard to try to convince them they should carry Extraterrestrial. It's something that I've been working on with them. So you can always pick Mysterious Galaxies to support. Buy Extraterrestrial. It's a really important and powerful book. It's one that I think is eventually going to be remembered as like one of the first most important books towards making that leap to being a part of a galactic community and not just an international community. But that being said, I've got my favorite astronomer here. Next thing I want to talk about is the idea of space archaeology. Like, how important is space archaeology as a concept that people haven't really thought of before, but it's a new thing that you and a few of your colleagues are really trying to put out there. Can you tell us about that?
The most important aspect of space archaeology is that it can teach us an important lesson to get our act together, because we might find civilizations that died as a result of not behaving in a smart way. For example, they fought each other, and so we might find the burnt out surfaces of planets and planets where clearly there was a nuclear war, or we might find extremely polluted atmospheres by industrial pollution, where there is no trace of life on the surface, but obviously there was a climate change. You know, these are lessons for our civilization, not to end that way. So it's just like taking a class from the sky, you know, learning what we can from what happened to others before us. And, you know, it's part of our history lesson, and we should learn that. So that's the most important aspect of it. And I hope that once we see other civilizations that died, we can figure out why and try to avoid that. And, you know, it could be as a result of a natural process. Like, for example, the dinosaurs were killed by an asteroid that hit their planet, and the dinosaurs didn't have astronomy. They didn't have telescopes. They couldn't forecast the fact that this giant rock is heading their way. It must have been an amazing sight to see the rock getting bigger and bigger for a few seconds or minutes until it hit them, and they couldn't prevent it. We can prevent it. And if we find planets where something catastrophic happened, we might prevent it. Of course, the star itself may burn up a planet. The sun within 1 billion years will get too warm, and it will cause a greenhouse effect on Earth that would boil all the oceans, similar to what happened on Venus. You know, the surface temperature of Venus is inhabitable right now. And so we could learn from looking at the sky. It's just other systems that went through different histories, and if we figure out what happened to them, we can learn from it. But
we can learn how just amazingly important this planet is, because this is the one that we're able to live on, and it could also teach us just how important that one little island in the universe is, which...
Right. It's just like reading stories about divorces and realizing that your marriage is really valuable, you know. Yeah, I agree with you. And but other than that, doing archaeology is a way of figuring out how unique or how unusual we are, because you find evidence for civilizations that existed in the past. Now, even if they were short-lived, still you can see relics that they left behind. They may have left industrial pollution of the atmospheres. They may have left mega structures, you know, a swarm of satellites. We are launching now satellites for communication, and within a few years, there might be 100,000 of them around the Earth. By the way, that's one of the future problems for astronomy, that these communication satellites that SpaceX is launching reflect sunlight, and even at night, they are quite bright, and they prevent a clean view of the sky. So for example, LSST on the Vera Rubin Observatory will be very much affected by those. Yeah. And there is work, there is communication of astronomers and SpaceX engineers to try and figure out, you know, how to code these satellites such that they will not reflect as much sunlight.
Yeah.
So anyway, you can look for those structures in other places.
Speaking as a stargazer who keeps his astronomical binoculars right by the door, you know, well, you know, yeah, the SpaceX thing is driving me nuts. But every time I look at Vega, I use Vega when I'm talking to people who don't know the night sky. I always point to Vega and point out that it's 25 light years away and that you're seeing the light from 25 years ago, whatever. But isn't every time we look into the sky, we're looking back in time. Every time we look up at the night sky, our eye is time traveling in tons of different ways, because each little point of light is coming from a different time in the universe. And so I always like to tell people that all astronomy is space archaeology in a way, because you're always looking back. Like every view we have of the universe, because of the way, you know, physics works, is coming to us from a different time. So
that's true. But the thing to recognize is that, for example, in the Milky Way galaxy, distances are at most tens of thousands of light years. Okay, and even 100,000 years is a short time relative to the age of the universe, or to the lifetime of the sun. You know, the sun would live for another 7 billion years, you know, and so relative to the characteristic lifetime of stars or galaxies, we're talking about very short times, and therefore the view that we see is pretty typical. Now, of course, there are transient events that take place for a very short time, and those, when we see them, like a supernova explosion, they took place at a time that is the light travel time back in time, you know, from the time that we see them. But as we get to the edge of the universe, the time that it took light to reach us becomes comparable to the entire age since the Big Bang, entire time that elapsed since the universe started. And therefore, we are seeing how the universe looked like at early times, which is fantastic, because there is a way for us to actually get images of what used to be the universe early on. And we have such images going back to when the universe was about 1 billion years old, you know, just less than 10% of its present age. We have such images of what it looked like. And it's sort of like a time machine, but not really. What we are doing is looking very far away and seeing light that arrives to us just now that was emitted very early on in the universe. And the first light that we see from that early universe is actually the cosmic microwave background, the relic radiation from the Big Bang that tells us how the universe started.
And one of the key people who measured that is a local here, Dr. Brian Keating, who I see at science fiction book events around San Diego and have been able to talk to, and had on my podcast one time before. And so, yeah, the fact that we can measure the cosmic background radiation is just as mind-blowing as.
And by the way, it provides about a couple of percent of the noise. You know, in these old television sets that were hooked up to antenna, you would see white noise if they didn't detect any signal, right? And this white noise, about 1% of it is coming from the Big Bang. These white dots that you see on the screen that is not receiving any signal. So actually, the microwave background is not difficult to detect. It's pretty bright, and it was detected in the mid-60s.
Yeah. Well, and you know, I think the fact that we're able to age the universe in a way is really cool. But also one of the most cool and speculative ideas is that there's only so much of the universe we can actually see with the technology that we have. And the fact that we can see, that we can take a Dobsonian out to a dark sky site, like San Diego Astronomy Association out here has a dark sky site, and they have monthly star parties, or they did before coronavirus. And, I would take some of my coworkers out there, and then the fact that we could get four, galaxies in an eyepiece or whatever, is one of those things where it's mind blowing, but no matter how good our technology is, there's only so much of the universe we can see, and we know there's more than we have the technology to see now.
Right, but I should say that one of the biggest advances in astronomy these days is that it's becoming multi-messenger. So traditionally, astronomy was about detecting light, that telescopes detecting light. But as I mentioned, in 2015, a gravitational wave was detected for the first time, and the Nobel Prize was awarded in 2017 for that by the LIGO collaboration. And that opened up the door to events that are detected only in gravitational waves. They produce no light whatsoever, like two black holes colliding. And it's called multi-messenger astronomy. So now we can use not just light, but also gravitational waves. Sometimes we detect both light and gravitational waves when two neutron stars collide. And one way to summarize the story of Oumuamua and the book Extraterrestrial is to say that I'm advocating a multi-messenger SETI, search for extraterrestrial intelligence, in the sense of not just looking for radio signals, but also looking for physical objects that may come and visit us. These are different ways to search for extraterrestrial intelligence, for a technological civilization out there. One has to do with light that is emitted, radio signals that arrive at the speed of light. And the second are objects that are sort of like a message in a bottle that move much more slowly. It's similar to the distinction between speaking on the cell phone with another person and receiving mail through surface mail that is much slower, reading letters. And then it's clearly a very different way of communication between us and the sky. So multi-messenger SETI is the way of the future, in my view.
Okay, now I've taken up a lot of your time, but I have one very fun last question I have to ask you, which is, all right, Avi Loeb, this is a safe space for the weirdest ideas that you have. I know you do a lot of your weirdest thinking in the shower. You talk about that in the book, and but what are 2 or 3 of like the most out there ideas that you know you can't prove yet, but are things that you're thinking about? Because you're talking to a science fiction writer and a bunch of science fiction readers. Like, give us the good stuff. What's some really weird things that you've thought about that you would like to one day prove?
Okay, well, I should disclose that I'm not shy, that when I have good ideas, I publish them. And as I told you, I'm not afraid of what other people think. And so I can tell you about two things. One, when did life, and especially intelligent life, start? That's a very interesting question. I mean, obviously, it's very likely that we are not alone. And people often think in the context of our neighborhood, just the Milky Way. But if we think more globally, it didn't necessarily start just in our neighborhood. It started in every galaxy that had similar conditions. And the galaxies, stars formed very early on in the universe. And so when did the intelligence start in the universe after the Big Bang? And moreover, can we detect it? Can we detect signals that would mean that they are artificial? And just to give an example, just this morning, I thought about something that I haven't thought about before. So, I still have ideas, which is a good thing. At some point, I will not have ideas, then maybe I'll go into politics or something. But the idea that I had this morning was that we have devices called free electron lasers. And what they are, I will not get into the details of the machine, how you make them, but they're tunable lasers. They are lasers that you can tune the frequency of or the wavelength of. So they're not based on an atomic transition that has a specific wavelength. And so you can tune it to any frequency you want. And so imagine another civilization producing a very strong beam from a free electron laser, which is a technology that we have, and we can produce spectral lines ranging all the way from X-rays down to ultraviolet, visible light, radio waves, all of any frequency we want. There are free electron lasers that can operate it. So imagine another civilization harnessing a significant fraction of the sunlight that is intercepting their planet, converting that into a very tightly collimated beam of light at a specific frequency that has nothing to do with atomic transitions, okay? So then we will see a source of light coming from a galaxy, and we can measure the redshift of the galaxy from spectral lines associated with the interstellar medium in the galaxy, or with stars in the galaxy. So we can, based on atomic transitions, we can tell what is the redshift of the galaxy. Suddenly we will see a line that has nothing to do with any transition that we know about. Mm-hmm. That's a signal that would appear quite unusual.
So is that a signal we could potentially pick up from even outside of our own galaxy?
Yeah. So I estimated on the back of an envelope this morning that if you harness all the sunlight that is intercepting the surface of the Earth and convert it into a beam of collimated laser beam, then it's detectable all the way to the edge of the universe. But one thing to keep in mind, this beam of radiation will sweep across our sky because we are moving relative to the source. Source doesn't know where we are. You know, the beam is going in a given direction and it's tightly collimated. So we would cross it and it would appear as a flash of light.
So it's kind of like waving is what you're talking about.
Yeah, so looking for a flash of light from a galaxy at a single frequency that doesn't correspond to any atomic transition would be interesting to search for. I bet you that nobody searched for that as of yet.
They haven't.
And in principle, you can search for that as a function of cosmic time.
Yeah.
So this is just one example. You wanted an idea, you know, I wrote it down, but haven't yet published. But also, you know, what would happen in the future? I'm also curious about that. You know, when will life end and not be possible? And I'll just mention an anecdote. At some point, I wrote a paper that in the distant future, you know, all the galaxies that are receding away from us will run faster and faster because the universe is accelerating its expansion, and we will be left in the dark. And that's a very gloomy forecast. And I wrote a paper about that. And then I got an email from Freeman Dyson saying, well, maybe we should not accept this verdict, and maybe we should communicate with other civilizations to come together in other galaxies, come together and not be separated from each other by the cosmic expansion. Just move the stars together or something. And I told him, Freeman Dyson, you know, he was also quite imaginative. So I told him, I don't think it's practical what you're talking about, but potentially what one can do is, you know, a civilization can propel itself towards a place where there are lots of resources that would last for a long winter, you know. And that's the way things happened on Earth. You know, civilizations concentrated, ancient civilizations concentrated near the banks of rivers. So you can imagine a lot of civilizations going to clusters of galaxies where there is a large concentration of resources. And you know, you don't need to do much. You just need to propel yourself and go there. And so I'm curious about what will happen in the distant future and what our fate will be. But so definitely, you know, because that would affect how much my book will be read in 1 trillion years from now, you know, if at all. But
right. Well, and one of the reasons, and I didn't know about your book when I reached out to you to come on the podcast. And one of the things that I wanted to do was I wanted to open the conversation between the more speculative science thinkers with the science fiction readers. And I consider myself a scholar of the genre of science fiction. My other podcast, Dickheads, we talk about Philip K. Dick. And when I was reading Extraterrestrial, one of the things that I thought of is, at one point I tried to put my head, I was like, well, what science fiction novel do I think this reminds me the most of? And I thought of Stanislaw Lem, who's most famous for writing Solaris, the Polish science fiction writer. He wrote a science fiction novel in the 70s called His Master's Voice.
you know that he was an important member of the Manhattan Project.
Yeah.
So as a scientist, he was highly respectable.
Yeah. And but Stanislaw Lem wrote this book, His Master's Voice, and it's funny because if you talk to a lot of science fiction readers, they'll all universally tell you how boring that book is and how it wasn't very fun. But the whole point of the book was, it was about a failed attempt at contact. It was about like aliens reaching out with the signal, and we never figured out how to discern it, right? And a lot of people lost, that the title, His Master's Voice, was a not so subtle indication of what he was trying to say, right? And what I worry about, and the reason why I thought of the Stanislaw Lem book is that I worry that we're going to miss an opportunity to find this evidence and to look at this evidence. And so I greatly appreciate Extraterrestrial as a book, because I think what you're doing is really important. And I really hope people will go out and get it and continue to look for your work. I know you publish more papers than it's possible to keep up with.
I should say that it's not always a pleasant experience to be on the front line this way, because this wire is barbed, and I'm willing to put my body on the barbed wire so that others can pass over it to a better future. And that's what they say. I served in the military at a younger age, and there is a soldier that always, if there is a barbed wire, lays his body on it so that others can pass and move on. And I'm willing to play that role. It's not a pleasant experience, because, as you can imagine, some of my colleagues are non-flattering.
Yeah. Well, I appreciate the work that you do. So just to close things up, when does the book come out? Like, how can people find it? And what's the best way to follow your work?
The book is coming out on January 26, 2021 in the US. And after that, in more than 20 countries worldwide, it will be translated to many languages. You can find me on my website with all the contact information and some additional material about the essays, for example, that I write in Scientific American on a weekly basis at www.cfa.harvard.edu/Loeb, L-O-E-B. That's my website, and it will be kept updated if you want to follow what's happening next.
Yeah, and there's really exciting stuff. It's not just the Oumuamua stuff, and it's the breakthrough star shot. It's your black hole work. It's like, I'm one of those space nerds that follows the weekly space hangout, that follows Universe Today, and like listens to all those podcasts when I'm out with my binoculars looking at the night sky. And so yours is a voice that I'm very familiar with, and was just this is beyond an honor for me, and I'm just so excited to have you on the podcast. Dr. Loeb, thank you for your time, and hopefully we'll talk to you again.
Thank you. It was my pleasure.